Welcome friends. So today we are going to discuss the detailed solutions of set 4. So let's start. The first question: a light beam of intensity I0 is falling normally on a surface. The surface absorbs 20% of the intensity and the rest is reflected. The radiation pressure on the surface is given by x into I0 by c, where x is. We have to find out the value of x. So as you can see, light beam of intensity I0 is incident on the surface normally, so it should go it should reflect in the same path because it's normal incident. So to distinguish, I have shown it separately. So radiation pressure is the pressure exerted upon any surface due to the exchange of momentum between the object and the electromagnetic field. So 20% is absorbed, so 80% is reflected. So this reflected intensity I0 prime equals to 0.8 into I0. Now incident pressure is given by average of this pointing vector by c, that is average of pointing vector is equivalent to the intensity, so I by c, and for reflected IR by c. So what is the radiation pressure? Change in momentum, so change in this vector. So this is the incident one and this is the reflected one. Now it is changing the direction, so a minus sign is introduced here. So the radiation pressure is 1.8 minus by c, so the value of x is 1.8. so as I have shown for convenience to understand it easily, I have shown like this. This is the incident momentum, this is the reflected momentum, and this is the change in momentum. So these are two vector quantities, incident momentum and reflected momentum, and the change in momentum gives the what we call pressure, force, and now force per unit area gives you the pressure. Okay, so let's move on to the second question. It says the elementary particle cascade 0 is placed in the baryon Deku plate shown below. Okay, so to answer this question, so what will be the position of this particle, P, Q, R or S? So as you can see, this is delta baryon, delta plus plus. Delta plus plus means it has charge plus 2e. Okay, now look at this figure. This is the total image. So this is along y-axis I3 and along x-axis there is, sorry, along x-axis is I3 and along y-axis is y. This y equals to b plus s. B is the baryon number, s is the strangeness. So as you can see, this is delta double plus delta baryon, and the component is u up quark, and up quark has the charge plus 2/3 e. Okay, plus 230 plus 230 plus 230, it becomes plus 2e. And as you know that when you go left to this series, d is getting added, and when you going in this direction, s is getting added, so it becomes us. So what we have to find out? We have to find out cascade 0, means the charge will be 0. Now us, so what is the charge here? Plus 2/3, and strange quark had charge minus 1/3. Okay, so it's not becoming 0. So as you keep on going down, s is increasing, but this is also not this is making the charge 0, because u means plus 2/3, s is minus 1/3, and this s is minus 1/3. So plus 2/3 minus 1/3 makes it 0. So charge is 0. So this is the position of this cascade 0, and it is at R. So the correct option is R, means option C. Option C is the correct option. Let's move on to the third question. The expression for the second overtone frequency in the vibrational absorption spectra of a diatomic molecule in terms of the harmonic frequency of omega e and harmonicity constant chi e is. So as you know that for a vibrational absorption spectra of a diatomic molecule, nu v bar, this is in terms of frequency, equals to omega into v plus half minus omega into chi e v plus half whole square. This is EV, means in terms of centimeters square or something like that, not in terms of joule. So we know from the selection rule delta V equals to plus minus 2 plus minus 3 if it is the case. So plus minus 2 will give the first overtone and plus minus 3 will give the second overtone. So we have to find out the second overtone frequency. Fine. So we'll put delta V equals to plus minus 3. So for the second overtone frequency, delta nu V bar equals to E V equals to 3 minus E V equals to 0. And if you put V equals to 3 here, so you get this expression. And if you put V equals to 0, then you get this. The difference gives you the frequency. So the second overtone frequency becomes this, and after simplification you get 3 omega e into 1 minus 4 chi e. So option D is the correct option. Next, question number 4, the number of independent components of a general electromagnetic field tensor. So electromagnetic field tensor F mu nu equals to this, where A is the vector potential, 4 vector. So 4 vector is written like this. And electromagnetic field tensor, this is the form, you can check it. Okay, and it can be shown that this is antisymmetric. Now for an antisymmetric tensor, the number of independent components is given by DCR, where D is the dimension and R is the rank of the tensor. Now for any n cross n matrix, rank is 2 and the dimension, as you can see, it is 4 by 4. So dimension is 4. So 4C2, it becomes 6. The number of independent components is 6. And one more thing is to be noted, that if it were a symmetric tensor, then number of independent components would have been this D plus R minus 1 CR, where D is the dimension, R is the rank of the tensor. Next, question number 5, the partition function of an ensemble at a temperature T is Z equals to 2 cos hyperbolic epsilon by kt to the power n, where k is the Boltzmann constant. The heat capacity of the ensemble at T equals to epsilon by kt is x into nk. So we have to find out the value of x. So Z is given to be this. So U means internal energy minus delta L beta of ln Z, where beta equals 1 by kt. So we write it 1 by kt. So beta into e to 2 cos hyperbolic beta e to the power n. Okay. So if you take the derivative with respect to partial derivative with respect to beta, then it produces result like this. Now his specific heat capacity C equals to del del T. So it becomes point nkb sec hyperbolic square 1 means 0.42 nkb. You are allowed to use calculators. So you can find out this value 0.42. So value of x is equal to 0.42. Question number 6, the absolute value of this integral over the circle z minus 1.5 equals to 1 in a complex plane EG. Now as you can see, the origin of the circle is at 1.5 and we have to draw a circle of radius 1. So 1.5 here and 0.5 here. So radius is 1, as you can see. Radius is 1. So we have to for such a problem, we have to find out the poles. So as you can see, z square minus 4 equal to z equal to plus minus 2. So it's a pole. 2 poles are there. One is plus 2 and another one is minus 2. But look, pole minus 2 is not, it will be somewhere like this, minus 2. Okay, somewhere like this, and it is outside this contour, so we don't have to, we can ignore it. And next, z equal to plus 2, it is lying inside this, so it is lying somewhere like this, so it's lying inside the contour, so we have to take into consideration. So residue at z equals to plus 2 equals to z minus 2 into this by this, so it produces the residue at z equals to plus 2 to be plus 13. So from Cauchy's integral theorem, twice pi I into sum of the residue, here sum of the residue is 13, so it becomes 26 pi I So that is equals to 81.64. Next question number 7. The ground state energy of a particle of mass m in an infinite potential well is E naught. It changes to E naught into 1 plus alpha into 10 to the minus 3 when there is a small potential bump of height V naught equal to pi square h cut square by 50 mm square and width A equals to L by 100 as shown in the figure. Then the value, what will be the value of alpha? So this is the figure. As you can see, this length is L. So if it is A, then this end, this point is what? L by 2 minus A, and this end is L by 2 plus A. Okay, so we are naming it alpha 1 and alpha 2, and A is given by L by 100. Okay, so the first order correction in energy equals to psi star psi dx. So psi equals to root over 2 by L into sine pi x by L. So psi star psi means root over 2 by L whole square sine square pi x by L, and we have put the limit of x. We are integrating from here to here, these two things. So upon integrating this, you can see, you can check the calculation, and I think this is correct. So you will get a result like this, 0.80. So let's discuss the question number 8. An electromagnetic plane wave is propagating with an intensity I equals to 1.0 into 10 to the 5 watt per meter square in a medium with epsilon equal to 3 epsilon naught and m equal to mu naught. The amplitude of the electric field inside the medium is, okay, so I is given. As you know that intensity I is given by half epsilon v e naught square, where v is the velocity of the wave, epsilon is the permittivity of the space where the wave is propagating, and value of epsilon is given to be 3 times the permittivity in free space, and mu equals to mu naught. So from here we can find out the expression of E naught square, and that is equals to, and here we have put the value of V to be 1 by root over epsilon mu. As you know that when it is C equals to 1 by root over mu naught epsilon naught. So when it is V, it is 1 by root over mu epsilon. So E naught square equal to this. Now we have placed mu equals to mu naught means 4.10 to the minus 7. This value is already provided, and epsilon equals to 3 times epsilon naught, or 3 into this is epsilon naught, and it results in this final number. So this is the answer, 6.6 into 10 to the minus 10 to the power 3. So 6.6 is the answer. Now question number 9. 4 MeV gamma rays emitted by the de-excitation of 19 fluorine are attributed, assuming spherical symmetry, to the transition of protons from 1d 3/2 state to 1d 5/2 state. If the contribution of spin orbit term to the total energy is written as C into L dot S, then the magnitude of C will be. So you can think the situation like this. So 4 MeV gamma rays are being emitted. So contribution of spin orbit term to the total energy is this. Now for 1d 3/2 we have these many specification. So as you know that this is equivalent to 2s plus 1. So 2s plus 1 equals to 1, means s is equal to half, and this is J, and D means SPD. So 0 1 2 0 1 2 SPD. So something is wrong here. It will be L equals to 2. Okay, this is wrong. L will be equals to 2. Anyways, it will not matter because ultimately these will get cancelled. Okay, so J equal to L plus S. So J square equal to L square plus S square plus 2 into L dot S. Now J has eigenvalue J into J plus 1 into H cut square, and L square eigenvalues we can write L into L plus 1, S square is into S plus 1. So if you put these values, this L and S will not matter, but J are different, so J will contribute to this energy expression and it will produce 5/2 C. So C goes to 2/5 into delta E. Now delta E, value of delta E is given to be 4 MeV. So putting the value, we get C equals to 1.6 MeV. Next, this is the last question of this set. So given this differential equation, d square f by dx square minus 2 into df dx plus fx equal to 0, and boundary conditions, f is missing here. F of 0 equals to 1 and f of 1 equals to 0. Then what will be the value of f of 0.5? So this is simple differential equation. So you can write d square minus 2d plus 1, or you can also write m square minus 2m plus 1. So you will get two values, 1 and 1. So these are equal roots, so the form of the solution will be c1x plus c2 into e to the power x. If it were different root, then it would have been c1 e to the power m1x plus c2 e to the power m2x. But here we encounter equal roots, so the form will be like this. Now we will use the boundary condition. So f at 0 equals to 1, so 1 equals to, this term vanished, so c2 equals to 1, and f of 1 equals to 0, and it produces c1 equal to minus 1. So this is the solution, f of x equal to 1 minus x e to the power x. So f of 0.5 will be 1 minus 0.5 into the e to the 0.5. This value is already, you can calculate this value using a calculator, and finally you will get this result, 0.82. So this was all about question set 4. So I have described all the solutions of all the questions. So if you have any confusion or question regarding these problems, you can comment below, and set 5 will come soon, so stay tuned. And if you did not subscribe the channel, please subscribe it and press the notification on. And finally, thanks for watching.